look.
Yeah,
Brent
that's the
spent
best
his-
cover. So I want you guys to just stew on this for a second. So you got these gross humans. We're very emotional. We're swearing. And then you've got this mother robot that's protecting her child robot from, because robots are very impressionable, really good at learning. And it doesn't want the baby robot to hear what the humans are telling. So we're actually going to put this together as a press piece. It's kind of a fun story we've wanted to do for a while. And this meetup was honestly a good excuse to just kind of get that across the finish line.
Are you trying to say something with the colors?
We kind of leave that up to bronze. I don't know. I guess it's angry. I love everything bronze does. Oh, with the red and blue? I don't know. We talked about putting like a Provo-specific hint in here, but that would be good. Make those BYU fans or something. So I'm just curious, how many people in the room would consider themselves engineers and not data scientists? Okay. How many people are on the data science side? How many people have seen us present before? Okay, good.
Define us.
Oh, you see me. So David's here too. Okay. So for people that have seen us present, there's going to be some recycled content on like background, introduction, some of the examples. But the second half of this is all new, focusing on the results with building models to predict a word. So for people that don't know me, I think the most memorable story about my background is I lived in a tent in Logan. So I just did that full time, and I slept outside. So I went to school, 19 credit hours of engineering, and I go sleep in the woods. And it made national news because I think it was weird. I was just going through the hippie stage, I guess. There's lots of fun stories associated with that, but most people remember that story. That's actually a picture of me reading in my tent, which is really stupid because I would never read in my tent. Like that sounds like a lot of work. I'd read at the library. But the journalist that took that image, which I'm now grateful they did, they staged it. So I never once studied in my tent. It's a lie. Really enjoy backcountry skiing. So anyone that likes touring, that's something I usually try to find an excuse to get out. This is an image I took. That's Ryan Debenham. He's over at Route now. So I took that image last spring. It's a magical day. That's Mount Superior, by the way. So my background, I studied chemical engineering with a biomedical emphasis. I did a research project with Genentech where they lyse Chinese hamster ovary cells. So they engineer them to produce human growth hormone, they lyse them, and then they go through this very long, expensive purification process. Because if you're injecting that into your system, you want to make sure that there's not other parts of whatever comes with that. And then I got into computer vision. I did a satellite research institute stint where I was predicting algae content in Antarctic sea ice from multiple satellite feeds, which was really fun. And then for graduate school, I focused on, again, computer vision, gold particles, doing automated particle analysis. So you get a high resolution image from a SEM machine where you might have 3,000 particles in one image, and we would want all those summary statistics rather than going and measuring them by hand. There's classical computer vision algorithms to do that have been around for a very long time, like decades old. It's not new stuff. The exciting thing that we'll be talking about in this talk is with deep learning, we have new stuff. It did not exist, at least it didn't exist in industry before 2014. Some academics were familiar with it all the way back to like 2007, and you might argue a little bit before that. I worked for IM Flash, did that for 5 years. Worked in photolithography where they print the circuit. So that's a NAND flash wafer. And then I also worked in process control and did some yield analysis there. And I went and worked at a hedge fund, and I worked at HireVue, which is an HR company here in Utah. And then for it'll be 3 years in January, David and I co-founded Zeff, which is now Zeff, Z-E-F-F. And when we co-founded it, we wanted to focus on unstructured data because it was a real pain to do anything useful. And we had both had previous experience at other employers trying to consume unstructured data. It wasn't easy. It was blue sky development, needed big hardware, and it wasn't something you could do overnight. And the goal initially was, how do we enable an engineer to do the same things that we do? So I'll go through a few slides to kind of introduce the business. So this is our motto or slogan: transform your business with an AI in weeks, not years, with your existing team. So we're really excited where we are now. We feel like we can do things on our platform. We feel like engineers can do things on our platform without a proper data science background that a lot of data scientists, including us, would be overwhelmed to do from scratch. And we'll get into some of those problems. I have a lot of fun with the marketing side of things that we get to play with. So some of the marketing pieces, to kind of intro, is we did this piece last summer. This is when we show, when we present who is real and who is fake. And I know some of you guys have seen this, so have you guys seen this before? Okay. So some of these people could be real and some of these people could be fake. Who is real and who is fake? So the computer is intentionally trying to trick you. And normally when we go through and quiz an audience, people kind of gravitate towards E. She looks a little strange, but they're all fake. So they've all been created by an AI. The thing that was unique with us is they've been created to hit targets or goals. So their race, their age, their gender, their level of attractiveness, even, I don't think we did ancestry for this one, but all of that was desired and produced. So if you, this isn't we've been surprised how many inbound requests we've had from companies you've heard of where they're really interested in doing something like this, where they can get humans out of the loop in their marketing campaigns. So rather than doing a photo shoot with a human model that might cost tens of thousands of dollars for a large company, they can now see daylight on potentially having multiple advertising campaigns that are optimized for certain demographics in certain locations, and they don't even have to be real. So if you want to exaggerate beauty or whatever gets people to click, that's fine.
Do any of these models have Instagram accounts?
These do not.
That would be really interesting.
But that sounds like you created models who do.
Oh, there's other people that have fake Instagram
Right.
accounts, but they're made from artist renderings. So imagine an artist making like a CGI model that they spent a month creating, and they have that on some Instagram accounts. These are just cooked up.
I was just thinking, there's that fake Instagram profile of the guy, construction worker, who like drinks coffee.
Oh yeah.
I was just thinking, like, imagine, like, you're not trying to fool anyone, but I just think it'd be interesting to showcase what you can do, like, let's have an Instagram person who's just AI.
This is definitely kind of fun because, well, it's fun, but it also starts to kind of blur some ethical boundaries that make people feel uncomfortable because AI is really good at manipulating us, and it's getting better and better, and it's already doing a really good job. So if you look at people that walk down the sidewalk staring at their phone, they're getting little dopamine hits every time they get a like or they engage on whatever that platform is, and there's algorithms that are trying to incentivize that engagement. But it's not a big stretch in the future that the advertisement you get is literally just for you, and the color of the eyes and everything about the model, you are more likely to click on it than I am. And there's just hooks in this AI machine to do that. And so some people start to feel uncomfortable. Imagine doing an input, like today, if you went to H&M and they were able to get you to buy twice as much stuff, you wouldn't be that upset. But there's a scenario in the future where AI's kind of cracked the code for your brain, and it's forcing you to impulse buy or have some desired outcome attached to money. You'll drool in your VR bed and do everything you're supposed to. So there's like a slippery slope to something that sounds like science fiction. So something that's less controversial or weird is, we did this a couple years ago, and this is really important. I want you guys to understand what's happening here because we're going to talk about it later when we're looking at the effort results. So something that's fascinating with deep learning is people feel like it's a black box. They actually don't like it for some applications, and that's a problem for industry because for most industry applications, you need to defend what you're doing. So we work with insurance where we predict loss on a property. We need to be able to tell you why a property is not going to be insured. And so there's a storytelling piece that needs to be unpacked. So we've been working for the last couple of years, figuring out ways to unpack deep learning, and other researchers have as well. And this is a really exciting way to do it. It's a little crunchy to digest. I'll explain what's happening. So we trained an image classifier to look at an image of a person and predict which country they're from. So which country did that photo, was the photo retrieved from? And we had 220 country zones, and we trained a classifier. The fascinating thing is when you train that classifier, there's actually something inside the net right before the classification layer. It's called the encoding or the embedding layer. And that is really interesting. It has actually learned different features. So if I built one for gender, beard, hairline, lipstick could actually be features in that vector that are they'll activate. So if someone has red lipstick, it'll fire. If someone has a beard, it'll fire to help make the decision on gender. So taking that embedding layer, we can have the computer organize it. So vectors that are similar will end up closer together, and vectors that are dissimilar will drift apart. And doing that, if we average it by the country, we actually get continents. And so we think of these as topics. And so assume you knew nothing about this data set. You said, okay, go train on this target. Now find topics that a domain expert can review. So we were pretty happy to see this because you can see we've got Africa down here, the Caribbean, Latin, Oceania, and a lot of this stuff actually makes sense. So the Caribbean should be close to Africa because there's a lot of African ancestry in the Caribbean. Then you've got Europe up to the right, Middle East. And then the really fun thing with this use case is, got a little bit ahead of myself. For people that don't know, who haven't seen this before, any guesses which country this individual's from? She's not from the US. So if you had to guess, just looking at someone saying, I think you're from
Alaska.
Alaska. Any other guesses?
Mongolia.
Okay. So Alaska is actually a really good guess. So it's not full credit, but it's more credit than maybe Mongolia. A lot of people will guess Mongolia. So this individual is from Greenland. And Greenland is fascinating because it wasn't settled from the east, it was settled from the west. And so the nearest relatives to Greenland would be Alaskan natives, and even further would be Mongolia. And you can see right here, just doing this topic clustering, Greenland is placed really where it should be genetically. So this isn't like a perfect genetic mapping because we don't have the genetic data, but just based on facial similarity, this is pretty interesting. Does this make sense? So taking a country and all these embedding layers, we average it, and the fact that Japan is further away from Australia or Zimbabwe, they will drift apart and move closer together. The countries that are similar, where you might mistake someone for being from another country. Another fun one that we did is, this was really flexing small data sets, predicting the bachelor outcome. So just training on less than 300 images, can we rank a season? So this is an example of a regressor. So a neural net is not predicting a class, it's actually predicting a continuous value. And then that value is used to rank contestants. And for this example, this is an unseen season. So for season 22, the net actually outperformed the contestant. So the bachelor picked someone and then changed his mind 2 weeks later. So he picked the AI's third pick, and then 2 weeks later, he changed his mind to the AI's #1 pick. So this is a fun example because it's predictive. We use this for an ethics discussion because we can look inside the model and we can show you the model is racist, it has beauty bias, and it has an age bias. And no one is surprised by any of that because they've already blogged about it publicly. Like, people have already blogged about this without the help of AI. They've already blogged about problems with this type of reality show. The really fun thing that we saw with this is we found what looks to be genetic biases. And so for whites on the show, if you are perceived to have Scandinavian ancestry, you will do better than if you're perceived to have Prussian, like German, Austria, and Switzerland ancestry. So even for whites, that's not an even playing ground. And but yeah, really these results are kind of embarrassing for the contestant because all of that dating really matter? Did the personality really matter? And
He picked the bottom one.
Yeah.
That's what he picked.
so we showed this in Chicago, and we did an out-of-sample test for every season. And The Bachelor is more predictive than The Bachelor. So it's easier to predict what men will choose than women for the show. They're both predictive. And it was funny because I think season 16, there was one season that was not predictive. It was still better than random. So we could throw away half the contestants, but it didn't do as well. So some of the audience, it was a big audience. It's like 100, 150 people. Some of the audience asked why the AI didn't do well on season 16. And I told the audience, season 16, The Bachelor was actually a good guy. Like, everyone's just a scumbag. So it was really easy. But he was the only one that actually considered other features.
What's the x-axis on the chart?
Oh, so this is, sorry, I didn't label it. So this is predicted and actual. Yeah, it's just a ranking.
Faces taken into account for this.
Only faces.
Only faces.
Yeah, and just one image of a face. Because you could get better results if we consume video, speech, and we have capabilities now that if you went through the work, of making that training set, we would support that for you. So you can actually put that training set through a platform with the video and get full credit for the video and the audio and all of that, and I think you would do better. This was done with just a single static face. And this shows you the average bachelorette. You can see why it's no surprise that there's racial issues with the show. One of the projects that's in the queue for marketing that we're getting a lot of attention for, and this is actually going to be part of the Data Science Go keynote end of September, is playing with using deep learning to play Call of Duty on an Xbox, which we're really excited about because we were able to kind of bridge that hardware gap. And I'm just really excited to start playing online in a live environment. It's kind of this Pandora's box on who are you playing with. A lot of people try to cheat today with packets and different things. But it really is an even playing ground that the AI is consuming the exact same pixel data that the human is, but the AI is able to react faster than the human brain. AI can multitask better. There's really exciting things that are coming from this. So this gameplay has actually been trained on a professional player who was fascinating to watch, by the way, but he's created 3,000 kill fight sequences, which probably translates to tens of thousands of kills that the AI can use as a baseline. Okay, so next. Okay, so another way to tell a story, and I think it's good to show this, and then we'll start unpacking something else that we're going to be talking about. So deep learning is fascinating because it doesn't work exactly like the human brain, but it's similar. There's some similarities. So why do you guys think this is a hummingbird? So I think most people in the room, they decided it was a bird, and then they decided it was a hummingbird. So does anyone want to volunteer why your brain decided this was a hummingbird?
Specific features and a specific orientation.
Okay. And what features specifically?
The beak, the eyes, the wings.
Okay. So these neural nets can show you their activations. In that same image, the beak and the eye and the wings were used for the AI to make that decision that this is a hummingbird. And then another example is Keira Knightley. Is Keira Knightley, if we were both women, if I was a woman, is Keira Knightley more attractive than me? Or let's say Hillary.
Yes.
Yes.
Definitely.
So beauty is interesting because there's a lot of interesting things about beauty, and AI being able to kind of get hooks in there and pull stuff out is pretty interesting. So why would you say Keira Knightley is more attractive than maybe a young Hillary Clinton, who I don't think is not attractive, but Keira Knightley is maybe top tier? Why would someone like Keira Knightley be seen as being more attractive?
I think part of it is that standards of beauty change over time. And if we're
Yes.
judging it by today's standards of beauty, then Keira Knightley is definitely more attractive than.
Yeah, so that's a great point because this should really be a whole discussion to kind of blow open, where if you look at some of the paintings hundreds of years ago, they celebrated women that were heavier because it was associated with people that were wealthy. The peasants were tan and the peasants were skinny and they were in shape, but that wasn't celebrated. It was this life of, that sounds, it's funny that things change. So now.
Explain the Kardashians with that.
Yeah. So Keira Knightley, we can actually have the AI show us why Keira Knightley is attractive. And kind of the same exercise with an audience, they'll talk about facial symmetry, they'll talk about the lips and the eyes, and AI is paying a lot of attention to those areas. And so, and we'll bring this stuff up in a little bit. So before I jump into this example, I want to show you two things that we do well. So one of the things that's unique about our platform is we solve holistic models. So the models we solve aren't just simple classifiers, they are mixed models. So they have text, images, different types of images, structured data. So one of the things we talk about a lot is all the data that matters. So when we're trying to solve a problem, we want to know what is all the data that matters to solve this. And then with our platform, engineers can design a record using our schema, and they can build very, very complex models. So this is a model that data scientists can solve. They can figure out a way to get there, but this is pretty overwhelming for most data scientists. Most data scientists would feel comfortable solving a single data type. So I need you to build a price predictor from text only. The majority of senior data scientists in Utah feel very comfortable doing that. I need you to build an image classifier, regressor, they feel comfortable doing that. When you start adding different images, so I've got street view, I've got satellite, I've got images in the home, I've got structured, I need you to learn different features for different types of images, that becomes overwhelming. And this is where we focused on because we can find a lot of value. So the most valuable problems in business, a lot of them end up being these hybrid problems, because the business will always have some metadata that is attached to a problem that's not being included. And this is something that most of this feedback and innovation came from engineers. For engineers that don't have an AI background, were giving us suggestions that shouldn't you know this, or shouldn't you include this in the prediction? And we didn't have any way to consume that in our pipeline. Another thing that we do is we're one of the only AI platforms that can build temporal models for video and audio. So an engineer can, this is an example of remote proctoring where we're predicting in a very long video, someone taking a high stakes exam, where are they cheating? So you decided 2 hours in this exam that you wanted to sneak in a peek at your book or something, or pull up your phone, or have a buddy come in. This is an example where they can build these AI systems where it'll get full credit for the video, the temporal, the spatial, and the audio. So if any of those features could impact the ability for the AI to predict, they will be considered. And this ties in well to predicting swearing. So back to what we're going to be talking about. So we did a project for a customer a couple years ago where we did tackle swearing, or predicting filtering. And one of the goals of this piece is we actually want to make a data set that we can share, where if people wanted to play with it, or if we wanted to use it in a tutorial, it's not a customer's data set. It's something that we can just share with you. And so before we jump into this, I want to give you a quick background on some audio insights. So David and I have both individually done a lot of work with audio. So at HireView, we did automatic speech recognition, and we built downstream models from that to predict interview outcome, to predict competencies, stuff like that. And we did build out automatic speech recognition in-house, which was a very tedious process. It took almost a year, and eventually they got really good results. So the HireView team is able to beat Google for the automatic speech recognition error rates And that shouldn't be impressive to say that HireVue is smarter than Google. It has nothing to do with that. What it has to do with is HireVue is training a model on their data. And that's the biggest issue with pre-trained models. So if you guys are consuming models from Google, Amazon, and Microsoft, they're not trained on your data. They're trained on different data sets that don't map perfectly to yours. So HireVue being able to beat Google for automatic speech transcription for dirty audio data on cell phones, that all comes down to the training set. And so some key innovations. One of the fun things with these type of networks, these networks are very, very, very complicated. Most people that tackle automatic speech recognition, that's kind of your full-time job. That's what your focus would be. It's not a hobbyist thing to do. I don't know any hobbyists training automatic speech recognition models. I know a lot of hobbyists that train image classifiers, image regressors, stuff like that. That's a weekend project. HireVue, when we were training our CDC speech nets, they would train for a month on a $12,000 machine, where the machine is completely slammed for an entire month, and this would be months and months and months of training, making progress. So one of the big breakthroughs with automatic speech recognition is they realized that it's not just the previous information, it's the following information. Have you guys ever been listening to someone talk and they say a word and you're not quite sure what the word is, but you wait a little bit and then your brain will go back and correct it? And so AI can work the same way, where it can take information that's coming in and then it can take information after the fact to make a smarter decision. And so a silly example I threw up there is if I said the Dark Knight, what am I talking about? That's actually not enough context. You guys don't know what I'm talking about. Am I talking about the Dark Knight, the sky at night, or am I talking about the Dark Knight, some medieval knight? And with enough context, you figure it out. And so AI needs the same playing field. AI needs to be able to figure out what are all of the elements. So this was a big breakthrough that allowed automatic speech recognition to start butting up against human levels. So Siri and Alexa are not the best that humans can do. I know they're some of the most popular automatic speech recognition use cases. But for at least 2 years now, maybe a little bit longer, Microsoft and Baidu have been saying that they have superhuman examples for English and Chinese, where they're beating a human at listening to the same audio.
So I messed around with the Baidu deep speech. Not necessarily speech to text, but speech to speech for voice cloning and stuff. And just because I'm just in reading that Baidu stuff, is there just a lower error rate, or do they, when they're training on that, or is it just because they're using different speech samples when they're doing their training, they're having more layers? Do you know why they might be performing better than other ones?
Yeah, the key thing there is their training sets. So HireVue has paid cash for proprietary training sets. I know David paid cash for huge training sets.
A waste of money.
That could have felt good.
So it's fascinating because anyone in the room, if they decide they want to, they can spend the next week downloading a curated data set of 10 million plus images that Google has offered you. It's free. You don't have to pay them. It's probably still true today, but if I had, if I had a USB that had 100,000, and David, correct me if I'm way off, if I had a USB that had 100,000 hours of like human transcription, it could be worth hundreds of thousands of dollars, if not millions, like if it's good. Yeah, $100,000. So just that data. So
What's that?
So 100,000 hours. So if I have 100,000 hours of audio that have been correctly transcribed for English, if you want that, it would be very reasonable for you to pay me over $100,000. And the reason it's so expensive is because for you to go and build that data set again, you have to pay someone. You have to pay humans to go and do that type of work. It's very tedious. It's not fast.
I would think that there would be public information about like courtroom transcriptions and things like
They're
that.
terrible.
Yeah.
All of the public stuff is terrible.
It's single speaker, you don't want
Yeah.
single
Yeah.
speaker data.
So we played with captions. So I'm sure someone in the room was like, captions. We saw a 10% error rate on captions. So captions, the captions are optimized for readability. They don't need a map to what was actually said. And so the other thing I didn't mention, so superhuman error rates are right below 4%. These are phenomenal numbers. And we were actually laughing just the other day. David was talking about some of their accuracies. And what were the word error rates you're hitting?
So our previous provider was about 28% error rate.
Okay.
And you guys probably have used products, some of you who are in like call platforms have used CallMiner. And they've gotten better. I think they're somewhere in the neighborhood of 19 to 20. And then I built a system based on just a standard DNN getting to, it was like somewhere in the neighborhood of like 18. So like,
It sounds terrible for people that aren't.
yeah, but it's hugely
proficient,
predictive.
but that's really, really good.
So are you talking about domain-specific audio or general?
And that ends up being really important, Joe, is like,
Yeah.
you know, the fact that we're listening to phone calls happening inside a tire store, like Google can't do that.
Yeah. So these models are very sensitive to the environment. They're very sensitive to the audio quality. They're very sensitive to the dialect of the speaker.
HireView's got people on their Android or iOS phones, like,
Yeah.
that is not studio quality audio, even single speaker.
So if I had 1,000 hours of medical record audio that had been transcribed, I could retire. Is that what you're saying?
1,000, you get 10,000 hours.
10,000 hours, I could retire.
Yeah.
1,000.
But audio is fascinating because these models, so I think HireView, their Docker container, when they first launched it, I'm sure they trimmed it down. It was 10 gigs. And the models themselves,
The container was 10 gigs?
yeah, the container was 10 gigs. So dealing with, auto scaling that. And then these models on disk can exceed a gig. And so for people that build deep learning models, with Zeff, we don't have any single encoder that ever exceeds 50 megabytes. And so to have a gig on disk, these are some of the biggest models that have been trained. So one of the big breakthroughs was the idea of bidirectional, which is kind of how our brains work. The other big breakthrough, I think, I'm not 100% sure, but I think this is credited to Baidu or the Baidu research team. They get a lot of credit for improvements in automatic speech. So they came up with a different cost function, which is this concept, it's called the CTC, where these two examples would actually get the same cost. So the fact that you have slightly different time spacing on when it thinks you said this particular letter doesn't matter. These would be considered the same. Where before, these nets were very sensitive to getting the exact timing right. And so this actually gives you more flexibility for AI to kind of learn and make progress. You don't want to have these really sharp, extreme errors. You want something that's a little smoother. One of the issues when they first came out with this, it was so expensive for you to calculate the CTC loss. And so Baidu was able to come up with a very special one that was really, really fast.
What does CTC stand for?
It's been years now.
Actionist temporal classification.
Yeah, thank you. So this was a really big breakthrough. Beyond this, a lot of the attention has gone into coming up with more aggressive convolutional architectures or bigger training sets. Baidu, one of their last white papers, they were training on 100,000 hours. So they took 10,000 audio hours and they were able to augment that by adding noise injection, which is a very common thing with deep learning. You like to augment during training because you need to have these deep nets generalize. So adding noise into the audio is a great way to do that. David's much more familiar with this. So at HireView, when we did downstream NLP consumption, we would predict competencies or we just consume raw transcripts and use them downstream. I've never actually dealt with redaction, but do you want to mention? Okay. So redaction is
A lot of NLP work.
And what are maybe the top 5 things for redaction? Credit card numbers, names.
It's the personally identifying.
Yeah, removal.
Yeah. Another thing too that came up is pulling topics is, maybe we didn't spend enough time on this. So for people that really think about it, a 20 to 30% word error rate. So these are word substitutions, insertions, and deletions. So almost every one in every 4 words is wrong. It's not readable. Nothing feels readable until you get really, really low, like probably less than 7, like really low. It doesn't feel readable. So to have word error rates that high, the idea of pulling out a topic or something, it becomes very challenging to get enough consistency.
Did you guys implement a language model to help with that, help reduce the error rate? Not with the NLP, well, the language model's an NLP thing, so.
So with the traditional like classic approach, you do a full-on language model. With CTCNet, your language model is essentially a spell check.
Because you do a language model, we kind of are app, so we use CTC. Yeah. But we're talking handwriting, which is really close to speech recognition.
Yeah, that really helps with your language model if you can reduce the possible options.
Yeah.
And when you have Alexa or some of these things with specific commands where you've really limited the potential things that could be said, then the opportunity to do something useful is high.
Like the very first the CTCNet coming out of, wasn't Alibaba, who was it?
Baidu?
Baidu.
Yeah.
Or CTC.
Yeah, their very first one, they just used LibreOffice as their language model.
Yeah.
So it was essentially a distance metric. It was a pure distance metric, how far away with the substitution.
Right, basically a search almost.
Just a beam search.
So, so now jumping into kind of the point of this talk, or the meat of this talk. So for this meetup, we gave a few options on different things we could present on. And this was a fun topic. We wanted to have an example of F words that could be shared publicly, where I was surprised. You actually, if you search Wolf on Wall Street, which is the #1 movie, I think they had one that just beat it a couple years ago, but Wolf on Wall Street has the most F words in any recent movie. It has 530. I assumed it would be really easy to just search the start-stop times on Wolf on Wall Street publicly. I just read it somewhere. And my Googling ability, which I think is good Googling, I've been Googling for a long time, I was not able to find start and stops. And so this is where I had to get a little creative. So for the training set, something that's interesting with machine learning is if your data set is dirty, if that fraction is small, you're okay. So taking the full movie, which is 3 hours long, I forgot it was that long. It's a really long movie. So taking the full movie and making the assumption that there are no F words in that clip, obviously that's wrong. You're gonna have like 1% of them. You magically discovered an F word. The way you tackle this is you produce these windows in time, and depending on how aggressive you are with your slider, you can create a massive training set. So with a 1 second window and with a 1/10 of a second hop, we just from this movie alone, we've produced 110,000 observations that are inputs to be predicted from DeepNet. Luckily, someone on YouTube, they produced a clip of all the F words. It's 3 minutes and 37 seconds. So it would have been really nice if they had given the metadata in the comment section. Their work was almost wasted, but this was helpful. So us having a 3-minute clip of all the F words and then having a 3-hour clip of no F words, when we sample this is actually just really dumb. It's literally just chunk, 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 chunk it's going through. When we sample this, we have to be a little bit smart because we don't just want to randomly grab, like we don't want to like split F words. And so one of the things we do when we're sampling this is we jump into a 1 second zone and then we find a peak, which is pretty common for these F words because F words have passion. There's kind of they're so mad. And that ended up being pretty good. So everyone's very comfortable. And this is, these are actually nonstop F words, by the way. This is coming from that clip. So this is like 20 F words. So we're very comfortable with this view for audio, which is amplitude or power over time. This actually isn't very useful. It's not a very useful way to consume the data. It's what we're the most familiar with. The most useful way to consume the data, and watch closely. So this is the same data set, but it's been converted to a spectrogram. So you can see what this was. The thing that's coming in the background is now an image. So we've calculated the frequency, space, and time, and we now have an image. That image can go into a convolutional net. So just like we had the image classifiers, and so something like audio that feels like black magic. The really fun thing about audio is audio is a breakthrough where AI starts to feel alive. So if I have AI in my house and I walk past the camera and it says Ben's home, that's kind of cool. But if I'm in my kitchen and I have a command word or a list of commands, let's say I have 50 commands, and if AI is perfect, that's the other thing that wasn't called out. Speakers are different. So if I have an AI system trained on me, I would actually expect really close to 0% word error rate. If I'm consistent and it's just trained on me, it should be right all the time, especially if I build up a decent training set. So that gets really exciting at home, because what commands do you want in real time to like activate everything? What do you want to happen? And so the spectrogram, creating an image, kind of breaks open this audio opportunity where now you can, what do you want to do? Do you want to predict a continuous variable like accent, latitude, longitude? Do you want to predict what country someone is from, English as a second language? In this example, we want to predict a word. So just taking those little chunks, by taking the 3 hours and chunking 1 second chunks, we've created 110,000 images in our system. And now we have 10,000 F words. So we have this training set. And one of the things we do, remember that country map that we built? So this is just the 120,000 F words. So they've been trained, something's been learned, and you can see that this is Provo, Las Vegas, New York. Like you can see these clusters of F words. And the thing that I'm not really unpacking for you right now is it's finding these granular topics. So there's different types of F words. There's a lot of different types of F words. There's ways to say the F word that happen in this show by itself.
So you're using.
This is
You're talking about places, but you're saying that.
the way it sounds.
Not literally Provo, but you're saying like.
Oh yeah,
There's
sorry. That was
there's an island that we'll call Provo.
Yeah.
That's
So whatever this
very
audio
benign.
is, there's something very similar.
That red spot on the island is my office.
So these are like, there's something consistent where all of these F words are very, very similar.
So one of the things you mentioned in building the model is that F words have passion behind them. So my question with this is, would you catch what is known as the casual F? You know.
Yeah, and so as of this morning, I know a lot about the F word. There's whispering F words, like so there's some that are really quiet, and we'll go through some of these examples. So a clear F word, like, so if I decide for no reason but to just let you guys have it, that is super easy to catch. Just really easy time box. There's some great sounds in the F word that are easy for AI to grasp. But if there's a lot of background noise, and I'll show you an example where there's a lot of noise or music at a concert and someone says it, and the human can hardly hear it, but it's in there. And so
every point on that plot of the F word or the red ones?
Only the red ones.
Okay.
So every point on that plot represents a 1 second window in time.
Gotcha. The spectrogram, okay.
Yeah. So so what this is showing you is for the whole movie, this shows you our confidence on the F word. And the problem with this visualization that I didn't fix before this talk is we're literally looking for needles in the haystack. So for us to find 1 second segments with really high F word confidence, like 99% confidence, that's really rare. They're there. We have, out of 110,000, there are 530 F words in there. So you are looking for a needle in the haystack. So what I wanted to do for this visualization is actually show you the big red dots. So it was really easy. It's kind of lost in this view. I'm going to walk you through some of these F word examples. So this is a spectrogram. There's no AI. It's just a spectrogram. With audio, we converted it. This is really interesting. We've actually never done this for audio. I actually haven't seen anyone do this, but we have these capabilities now to look at these activations, which is very helpful for image, but it's also surprisingly helpful for audio because our brains can't really unpack a spectrogram very well. But just looking at this activation, it actually shows me within this window of time, where do I think the F word is? Do I think the F word's over here? No, I think the F word is actually over here. So this is the same information, just looking at these activations. So in this 1 second window of time, if I had to guess where the F word was, I'd guess right here, and I guessed right. So it's actually really fascinating because it's an image making a prediction, but we actually know inside that window where we thought the F word was said. The more classical way for you to time box an F word would be to have like a 10 millisecond slide. Then you'll get your confidence and you get the spike. And we've done that before. You can get really good bounding on an F word, but this goes even further than that, where I don't have to do a 10 millisecond slide. I could do like a third of a second slide and probably get the same granularity on where I think this F word was mentioned.
Just a random question. Wouldn't it be just easier just to convert everything to text?
Well, then you have to use the automatic speech models. And so when you're just trying to go after a single command or a single word, like did you say it or not say it, this will inference really, really fast.
And it's very accurate.
Yeah, it's accurate and it's fast. What you said could be more accurate, but inferencing will be a beast. It'll be so expensive. If you're just looking for a word like the F word, this is the right approach just for productionizing it.
Just because it's faster?
It's faster. So for automatic speech transcriptions, those models are very expensive to inference. So just for me to go and actually do the full transcription.
Well, and even to retrain it. So if you want to add, the 7 words you can't say,
yeah,
that's an afternoon of training.
Yeah.
If you want to train speech to text, that's a month worth of training.
So there's this statement. Here's another one. This one's kind of drawn out a little bit. Who has ever said this? Second F word.
You're asking about today, right?
So
on the freeway, of course it is.
So this probably isn't as exciting to you guys, but I am so excited to actually know what side of this it's on. So to just have one prediction and say, I think you said the F word here, and seeing that it's lining up well is actually really, really fun. This is a whisper F word, but you can see it's activating right where the F word is said. But if you look at there's not a lot of background noise, but this is relatively quiet when someone says the F word. I've never said that in my life. I haven't said that one. This one was fascinating.
Oh, man.
All of these.
So this,
What planet are you on?
so this is a rock concert. Like you can barely hear this one, and you can tell. Like look at the audio. It's super, super loud. You can hardly hear the background. But looking at the activations, it is centering. Like it's still finding this F word.
So I'm wondering too, like since you're looking for human speech, right? Is there any kind of pre-processing also done in the data? You applying a bandpass filter on this, the spectrogram to kind of cut out certain frequencies, so you're just listening to where you're listening actually.
Yeah, so some people do that, and some of it is actually showing up in these activations. So like you'll notice it activates in this band. So this is frequency. It's activating here, and it's activating on these. I think those are high frequencies. The spectrogram is actually flipped upside down. But like this one's a little weird, but you see these two zones here that are lighting up. And so some people will do that. Another approach that might be a little bit more natural the way we behave today, we think of anything you're consuming, if it's unstructured, it needs to go through an encoding process. And so a more natural reaction to this that we might do internally is we would have a human speech encoder, and then the encoding output of that would be coupled with the F word detector. And that way it's actually not even activating unless it thinks humans are speaking and it thinks somebody's saying the F word.
So I know this is going back a few slides, but are you, when you're training your model, are you converting audio into a visual artifact and then training on the visual artifact, or is that just for the purpose of
The model trains everything we consume, video, audio, it gets converted into a visual representation. Which should make this, like playing with audio, if you're doing audio classification or regression, as soon as you do that, for a lot of people that do image deep learning, they should feel right at home. So this type of approach, you're not getting the full benefit for like the bidirectional. The way we operate, we would probably try to encourage the business use case to bring in additional data. So you have other structured data. Is there anything else you knew about this sequence that you can bring to the table? Because we get a lot of value doing that. But that'd be one way that you could improve it, but your inference would get expensive. Someone else had a question? So keep in mind that we actually didn't have a training set. We had this. We didn't have a training set of the original movie, time boxed. And by doing this and producing this output, it's allowed something that would take a long time to go through and find. It's essentially already found all of these F words in the movie. And looking at the top ranks, sure enough, they are F words in the movie. And so the thing I don't have today, but part of our tutorials that we're putting together is we will offer a Wolf on Wall Street start stop on F words, which essentially are right here. They're in the data already. And for whatever reason, that's not publicly available. Reddit really let me down.
Like Angel would have had it.
Yeah. Well, I don't know if that's public. So we want something that's public where maybe they don't even know.
They went bankrupt, didn't they? Now it might be.
I don't know the details. They've got a lot of different business arms over there, so it's really frustrating. Whoever that person was that did all the time to make the YouTube video, because that is not just audio; they're clipping the video, and that's a lot of work for someone. But they didn't offer that up. But already with this, so when we train, we get decent accuracies. We're getting 96% accuracy for this type of an approach. But with this, there are some F words that you just can't really, with this type of approach, training at this level, you can't really get. And the natural roadmap to get them would be train on more data. So 500 F words is not enough. Like you want to train on millions of F words to generalize and do better.
Got your microphone to Dave's office.
Oh yeah. Then we'd be really good at detecting his F words.
That's true.
So
they're always said with so much glee that
So you convert the audio bit stream into a spectrogram.
Yeah.
You're not extracting any data that's not already there.
No.
So the conversion to a visual medium, is that like for optimization, just like the tool chain that you have already established?
Yeah, the tool chain we have established, but so if you convert this into the raw spectrogram, you do have the opportunity to not go into unit 8, to just go straight float 32.
Oh,
You
gotcha.
can do that. The thing that is really fun here, I didn't show you a the way I want you to imagine this AI is if it's moving, if you're watching the video, you could actually visualize the AI thinking about F words below, where the activations are sleeping and then it wakes up. And so the spectrogram here, most of it's being ignored. But then when it thinks it's finding something interesting, and this really shows off the power of deep learning because traditional models don't have this type of feature flexibility. Traditional models would be very anchored on very specific regions in the spectrogram. So if you look at these activations, they're different. Like these two activations are very, very different. these F words are very, very different. They're different types of F words. But this model is generalized enough that it's still able to get these hooks. That's kind of the beauty of deep learning is the feature complexity compared to what you would normally have is much greater. I didn't post this on the slide, but one of the things we do on our back end when we're training is we baseline to more classical approaches to kind of understand how they do. And we see that these methods outperform them significantly. So there's always lift with whatever you're doing. You can run a Bayesian model on that spectrogram and get lift, but you won't beat the deep learning.
On these pictures, are the activations mapped directly onto the spectrogram?
Yeah. So those are the parts of the spectrogram to the left that is firing and causing a downstream outcome from that. And then this red line is just looking, because remember this is time. So this is time. This maps to this. This is just looking at the activations and adding them up. So I can see where in time am I getting the most activity, and that lines up with the F word. Okay. Any questions around? Yeah, it's actually, it's interesting because AI, a lot of stuff that feels like magic is becoming less magic-y. So, 10 years ago to do something like this and predict a word from audio to fill, you'd kind of have to be an audio expert. You have to do all these different things. You have to do the band filtering, where's human speech. It'd be a lot of work. And now converting audio to a spectrogram and training a deep net, you're handing off all the feature engineering to the deep learner rather than relying on a human expert.
I'm assuming you could use this to go through all your previous presentations and change Zeff to Zeff, right?
Good. It's funny, the name change
The lawyer hasn't called about that yet.
Yeah, we're just not very opinionated. It's been kind of a gradual change. I think we're pretty good, right? Like there might be a Zeff. I still use Ben at Zeff for my email way more than I should. But yeah. Any other questions in general on AI projects people were thinking about?
I'd love to see how this model would react to like a test set of Bowdlerized F words that you see in Provo and most areas in Utah.
Oh yeah.
Fetch and flip.
Oh yeah. I think you would find, the thing you're bringing up is one of the natural things we see with AI production is there is kind of a human handoff where these false positives and false negatives, you will want to lower them. We did a similar project with the F word for a client a couple years ago, and one of the false positives was something. So saying effing, saying something, just kind of the right, whatever, the right cadence, the right syllables, that ended up being a false positive. But normally what we see when you find a false positive, you just put in the human loop to, let's go find the false positives, because the false positives are gold. Get them back into the training set, and then eventually it'll become more sensitive to not firing on that.
A quick question about this feels, I'm not a data scientist, I just write software, but it feels like you could iterate over the same problem with multiple approaches, or even recalibrate something to, changing all the variables that you have going into this, from the width that you're testing and the speed that you're jumping.
Yeah.
It just feels like you could go from 18% to 17%, but to 16.8%. Like you could just
So
go over this first.
That's one of the parameters we allow the engineers to play with, is the temporal window. So if you had a really strong opinion that you think this would do better on a 5-second temporal window. So this is really small, this is 1 second. But if you think having the outside context could do better, that's something you could test. Normally you'd have to just dive in, write brand new vanilla Datasets code, but that's one of the things we want engineers to understand and test. And eventually, long term, we want to automate some of that testing, where we would actually give recommendations based on the data set that you gave us that we don't know anything about. Like maybe it's audio data from machinery, maybe it's speech, maybe we don't know. we would do different temporal tests. But right now, we'd have some best practice recommendations and you could test. Try a 1 second, a 5 second, and 10 second.
You ever have customers that come back and say, we want 0.1% more?
We would really like that because that would get expensive. Well, computational cost isn't free. And so if you want a 1 millisecond slide or a 10 millisecond slide, you just asked for orders of magnitude higher hardware consumption, which we're signed up for. Like we'll service that for you. But the appropriate thing would be to see what is the largest window you think you can get away with for your problem, because then your inference costs and your throughput go down. And automatic speech recognition is one of the most aggressive. They've talked about 10 millisecond slides. Super, super aggressive. That's why it's so expensive to go through and do these predictions for speech.
You said this gets to 96%. I think human level is 98%. What's needed to get that extra step of the way to get superhuman speech recognition?
A big part of that's just the training set, the size of the training set. There's probably some better augmentation strategies that are audio specific, like injecting noise and different things like that could help improve the accuracy. The big win is getting a bigger data set. You know, how can you increase your training set in order of magnitude with humans in the loop or something? That would help a lot. The other thing that would help even more would be bringing in some outside context or data. So if you know something about that situation, and it doesn't have to be an image, it could be structured data that you know Leonardo DiCaprio's in the scene, or you know something else that could help a lot.
What if you know that it's in a park versus in, you know, some really quiet, I mean, is that kind of what you're talking about in the context?
So the thing I'm hitting on is we would expect a domain expert or someone who knows the problem to have they don't even have to be technical. They would just have an informed opinion. This use case, this would be important, because we're just the AI solution. We don't know what's important. But if you had an opinion that anytime there's kids in the scene, or if you're at a park, you're less likely to have this happen. So.
You said machinery audio. Are you able to like listen to machines on a factory floor and tell them it's going to break down?
If they provided a training set, so if they said, here's some audio coming from this factory, we have outcome data, then that is a problem that I think you could.
Canonical data set for that. I can get you the name of it. So there is actually a training set that does machine reading failure based on sound.
In my experience, most audio classification is on environmental sounds or machinery sounds, not on speech. Speech is kind of the lesser use case for audio ML because a lot of it is speech to text first. People seem to prefer that mentally.
Yeah, and that'd be a great use case to bring in some of the manufacturing data. How long has it been since you've had a PM on this piece of equipment? There's all sorts of.
I want to know if my car's going to break down.
Oh yeah.
Yes.
So that
you better get your car in here because it meets the criteria noise-wise. That isn't right.
The other thing you bring up is one of the advantages you have with AI is there's certain sounds and different things that we're not even equipped to realize. So there could be a frequency that's outside of your range where, depending on the hardware that you have access to, AI could easily find it and pick up on it. And then same with visual. A lot of times we see go out of the visual spectrum, you'll find all sorts of things.
Yeah, you said that you took the shorter video with more F words to balance your data set more. Is that right?
I use it just to get labels to get started. So the preferred training set would only be the main one. That'd be the preferred way to go. And it wouldn't just be one video. You'd want to have thousands of videos.
Did you do anything else to balance your data set so it wasn't so much as finding a needle in a haystack?
So we have stuff in our system where we'll automatically do oversampling. So if you're sending in a skewed problem, it will be oversampled during training to make up for that. Because we find in industry, a lot of these really useful problems they're rare. They're 1 in 100, 1 in 1,000. Think about loss and insurance. Not every other home is a loss. It's 1 in 1,000. So how do you find that? And that's problematic for machine learning. So we've had to come up with ways to automatically take care of that during training. And we rebalance with oversampling, but then we do a lot of augmentation in our system to help things generalize. Okay. Questions? Okay. I don't want to keep people. I'm happy to keep answering questions if you want to.
I'll ask you a question about your slide way back on the predicting the origin of the face. You had that embedding layer, right? And yeah. So what did you end up using there to group those? Like a cosine similarity function? Or what did you use to tell these vectors were, those embedding vectors were in the same?
This is just a t-SNE plot. Yeah, so those vectors were aggregated by label and then they're clustered. And you could get similar value with k-means or some other clustering algorithm, but we really like the output that we get from t-SNE.
So it's unsupervised learning for this one.
Yeah, yeah. So once we produce those embedding layers, then we use unsupervised learning to organize everything. And we've been doing this on lots of different data sets, lots of different industries and use cases. And we see a lot of value in this approach for finding topics that a domain expert would react to. So if we're telling you there's roof damage, there's a topic in here that's very specific that we could have a human conversation around. What is something that was learned that is highly correlated with roof damage?
Follow up on the oversampling. Do you have to do any corrections afterwards? Because it seems like you would then have a trained algorithm that has a higher probability of finding these anomalies. Is there any correcting that you do after? I don't know if that's clear, but.
No, that makes sense. So what we found is during the training portion, we do oversampling. For validation and holdout sets, they have not been oversampled. And the natural, so this data set that you see where it has the long tail and the upwards, it was trained oversampling. And so I love the point you brought up that should be a concern, that you're seeing a lot of these anomalies more often, but you still get a model that is, kind of projects that.
So why does it work? I'm just kidding.
So one of the big issues if you don't do that is and this is why a lot of data scientists who've been in the industry for a while hate statistical metrics of success. So accuracy, AUC, pick your favorite metric. If you don't do that, you can have models that diverge on everything is good. And so the prediction will just be that. Like everything is not an F word.
It's accurate because you don't.
Yeah, like that would be accurate to 99%. Everything's not an F word and the model is useless. So with the oversampling, it can be more aggressive.
Is there a possible solution of using like I don't know the technical name for it, like a language model that knows context of how words interact? That way you can predict ahead of time if an F word is about to be the next word.
Yeah, so that might naturally be caught by using a bigger window. So this 1 second window is really aggressive. You actually have no outside context. When we were doing this before, we had larger windows, I think we dealt with 10-second windows where you've got a lot more context. And so that should naturally be captured that way.
So you said you use Baidu's deep speech architecture for training the model.
We did that in the past at Higher View for automatic speech recognition. This is just a convolutional net.
Okay. So for that deep speech architecture, did you implement it by yourself, or do you use any open source?
We started with Torch because at the time it was the only implementation of Deep Speech 2. Since then, it's graduated to a lot of different frameworks. But this was 5 years ago, I think. Like it was right after Deep Speech 2 came out. We started implementing it in Torch. And then
It was a joy.
It was so fun.
It was so joyful.
Yeah, it was so
not an engineer and he quit.
Yeah. The engineer working on it only worked on it for a year. That was all he did.
Another question. So for speech recognition problems, other than the word error rate, are there any other useful measures to you know, to measure the accuracy of error. My understanding, the word error rate is only one aspect of measuring accuracy for the speech recognition performance.
So a few thoughts. You might actually have a word error rate that is calibrated closer to the business use case, because there's probably some words in the setting where if they're mistaken to be the other thing could be really bad. And there's other words where you're like, you don't really care. So I think for a real application, you might actually have, I don't think anyone's ever done that, but a lot of times we just focus on word error rate. But for a real life application, you might have scenarios where you're really sensitive to certain word error rates or certain mistakes. Something that I was thinking about when you were saying that, one of the things we're very sensitive to when we deploy models into production is drift. So if you spend hundreds of thousands of dollars training your own speech net and you deploy it, and then you get a new customer that has different microphones or something, you might find out that you had an issue with your speech net from them complaining. And one of the things we see with AI is there's an opportunity for you to do internal quality checks on feature drift. So at HireView, we had a few excursions where an incoming feature that was being consumed from a vendor would be changed without our knowledge, and it would impact a downstream model. And so a lot of people that ship models into production, they start to become very sensitive to stuff that feels more like DevOps or maybe like statistical process, like almost like manufacturing, on how are we going to have alarms, how are we going to respond, how are we going to loop a human in, because the model's never changed. It's the data you're ingesting that changes. So, okay, I think that's, I want to make sure that, people that are interested in going can go. I'm happy to keep answering questions around happy topics, sad topics, scary topics, any AI questions.